Hi, my name is Noel Chapman and I'm a CQU University student. I'm undertaking ESSC12005 Exercise and Sports Physiology course. This course requires us to do a manuscript presentation. My manuscript presentation is on the physiological effect of active and passive recovery on university students during repeated running sprint ability. Repeated sprint ability has been looked at over a number of research articles. They found that field-based sports do on average 16 to 62 repeated sprints. When they're doing these sprints, they cover a distance between 10 to 20 metres in 2 to 3 seconds. Literature looking at active and passive recovery on physiological aspects of repeated sprints has found that blood lactate accumulation after sprints is higher in active recovery than it is in passive recovery. They've also found that active recovery is more efficient at clearing blood lactate levels than passive recovery. They found that active recovery shows slower repeat sprint times than passive recovery, and time to exhaustion is faster and fatigue is quicker in active recovery than it is in passive recovery. The aim of this study is to evaluate the effect of active versus passive recovery on repeat sprint ability and the associated physiological effects. It is hypothesized that active recovery will be more effective at clearing lactate than passive recovery, and passive recovery will produce less sprinting fatigue than active recovery. This study had 8 active male participants and 2 active female participants. Participants volunteered in this study. They voluntarily signed consent forms, and demographics can be seen in the table below. Study design. It was a randomized control crossover trial. The outcome measures were lactate levels, sprint time, heart rate, and RPE. Lactate levels, heart rate, and RPE. Lactate levels were taken pre-warm-up, post-warm-up, post-sprint completion, 3 minutes post-sprint completion, and 5 minutes post-sprint completion. Lactate levels were taken using the microtainer safety flow lancet. This pricked the finger and let the blood come out. Once the blood came out, it was wiped with alcohol wipes. The lancing replacement device, these are used so then we weren't using the same prick on the different participants. The capillary tubes, they were used to suck up the blood to put onto the yellow gauze strips, and then the yellow gauze strips were placed into the Accutren Plus, which calculated the lactate levels. Heart rate. So heart rate was taken pre-test, and then it was taken immediately after every single sprint and immediately before every single sprint. And then at the end of the 10 sprints, it was taken every minute for 5 minutes. The heart rate was taken using a polar heart rate monitor. Five-minute warm-up. So the 5-minute warm-up consisted of high knees, karaoke's both side, alternating sumo squats, and high knee pulls. These were performed to the 10-meter line. So we had to go from this line to here, and then we went back again, doing each exercise. The next part of the warm-up was just on the spot. We had to do 6 left and right leg swings and 6 left and right swing across. The final part of the warm-up was 4 individual sprints. One was at 70%, one was at 80%, and one was at 90%. And these were the whole length of the basketball court, from one end to the other. Active recovery. So there are 2 different recovery phases, active and passive. In the active recovery, the person would start, they would sprint through the timing gates, and then their recovery was a jog around back to the start. They had 22 seconds recovery. So they weren't allowed to get back to the starting point and just stand there. They had to jog the whole time. And then once they counted to 20, then you got ready and you sprinted again. And you did that 10 times. However, for passive recovery, in passive recovery, you'd sprint through the gates, you'd slow down, and then you come back to the start, and you'd rest there until they counted you down to 22 seconds. Then you do the same. You sprint back, slow down, come back to the start. So in passive recovery, you got to rest. Statistical analysis. So we did a descriptive analysis on the participants. This was done in mean and standard deviations. A two-factor repeated measures ANOVA was done, and then a significant result was found, so a post hoc t-test was conducted. Statistical significance was at 0.05, and Microsoft Excel 2013 analysis tool pack was used. Results. So as I said before, there was a significance in the ANOVA. From the results, I'd say that the significance was found in this section here. However, when we did the post hoc test, it was not significant enough. So it just didn't make it. Active versus passive recovery fatigue rate. So there's a massive jump in the fatigue rate from 5 to 10 meters. However, I think this was an outlier. So there was one lot of results that was quite higher than the rest, and yet was not found significant. Discussion. So literature showed that there was a significant difference between lactate levels in active and passive recovery. They found differences in sprint time between active and passive recovery, and they found differences in fatigue rate in active and passive recovery. One reasoning why we may not have found results is due to the fact that the tests conducted were different to ours. They were not the same in any way. Our tests was completely different to all those. A few of them were on swimming, cycling. There were a few on running which found results, but they were over different distances, and they did a different amount of sprints. Limitations. So there was only 24 hours between each test, which didn't really give the participants time to rest. Many participants were involved with other tests, which meant they were physically active in between the 24 hours, so once again, not giving them enough rest. Participants could eat and drink whatever they wanted. So there wasn't restrictions to what participants were eating or drinking, so they could have had a Red Bull before they did the test, whereas other people might have had a bit of fruit or something, so there could have been discrepancies with that. The warm-up was not consistent between groups, so when the warm-up was written down, it wasn't specified where you had to run to for the 70%, 80%, 90% and 100% one-off sprints, which meant people were going different distances, which could have meant they were more fatigued than other groups. Accuracy was minimised as there were a number of different people doing the experiments. Further research. So I think it could be, in further research, it would be good to set a rest period before the trials and also a rest period in between the trials, so you know that everyone's doing exactly the same thing. Set a food diary, so set some like a diary that people have to follow, so everyone's eating the same thing. And maybe you could look at gender differences. We had males and females in our group, but that wasn't assessed, so maybe in the future they could look at the difference between male and female and see if there's any differences in those ones. Conclusion. These findings indicated that the recovery conditions do not impact blood lactate, sprint time or fatigue rate. Practical implications. RPE showed levels between moderate and hard, indicating it could be a good exercise to meet daily requirements. Repeat sprints may be a way to improve cardiovascular due to the high heart rate levels seen. This test is not an appropriate tool to determine whether active or passive recovery is best for training sessions to get maximal results. Any questions?